Bismillahirrahmanirrahim. Today I will be discussing my lecture number 5 with you guys, which is related with the subject of soil mechanics. And the contents of today's lecture are soil description, the three phases of soil system, weight relationships, and volume relationships. Let me take start with the soil description. That in how many ways we can describe a soil system. We can describe a soil system by the nature of the soil. Okay, that is the first parameter with the help of which we can describe the soil. Because everywhere you will have to describe a physical quantity. For example, if I'm talking about you guys, so you are the students of civil engineering technology, then you are now studying in your third semester. Okay, you are the students of batch fourth. Similarly, I can describe you by your names, by your localities, that from where you belong. Okay, so these are just the different points of your description. Similarly, we can describe a soil system by using different parameters. Like the first parameter is the nature of the soil system, in which comes the shape of the soil system. Okay, that what is the shape of a soil particles, what is the shape of the individual particles of a soil mix will categorize the basically their soil system. For example, if the particles will be angular in shape, so in that case we will call the soil system as angular soil. For example, if the soil system will be spherical in shape, then in that case we will categorize the soil system as spherical soil system. Similarly, if the particles will be plate type, then in that case we will categorize the soil system as a flaky soil system. Different points of description. You can describe the soil system by the size of the particles. For example, if the particle size is much small, then the soil will be categorized as fine grained soil. And if the particles sizes will be bigger, then the soil will be categorized as coarse grained soil. Similarly, distribution of soil particles. In this, we can categorize the soil system by its gradation. For example, if the soil system will consist of particles of all sizes, then in that case the soil will be categorized as a well-graded soil. Vice versa will be for the soil system which will be having a particular sizes. Okay, and the other sizes will be absent, then in that case the soil will be categorized as poorly graded soil. You can describe the soil system by the state. Okay, for example, if the particles will be packed with each other, okay, in that case the soil will be called as dense soil. If the particles will not be packed with each other, they will not be compacted with each other, in that case the soil will be categorized as loose soil. Okay, the soil will be categorized as medium dense soil if the density will be medium. For example, the soil will not be too loose, but at the same time the soil will not be too compacted, and in that case the soil will be categorized as medium dense soil. You can categorize the soil system based on the water content. Okay, for example, if the water content present inside the soil mixture is more, then the soil will be categorized as saturated soil. If there will be no water inside the soil voids, then at that case the soil will be categorized as dry soil. You can also categorize the soil as partially saturated soil when some of the air voids will be filled with water and some of the air voids will be filled with water. Some of the air voids will be filled with air and some of the air voids will be filled with water. Then in that case, the soil will be categorized as a partially saturated soil. You can also categorize the soil system based on the fabric of the soil. Okay, that how they are made. For example, homogeneity. Okay, if all of the particles of soil will be made from the same crystals, okay, will be made from the same grains, then in that case the soil will be categorized as homogeneous soil. And let's suppose if the soil system will consist of particles which will be made up of different crystals, different minerals, then in that case the soil will be categorized as non-homogeneous soil. You can also categorize the soil system based on the layer sequence. For example, the soil is present at your site is a stratified soil or unstratified soil. Like I have given you the example of glacial till. When we were discussing a soil residual soil system, so I have discussed with you about the glacial till. Now glacial till is an example of an unstratified soil. So you can also categorize the soil system based on the layer sequence. Okay, if the soil will be laid in different layers with in pronounced form, then in that case the soil will be categorized as stratified soil. And let's suppose if there will be no pronounced layers and instead there will be a mixture of all the particles present inside deeper from the ground surface till the deeper depths, there will be a mixture of the material. Like for example, you will be having cobbles and boulders, you will be having gravel, sand, silt and clay. All of them will be mixed up. For example, glacial till. Glacial till is an example of an unstratified soil in which we are having particles of all sizes. There are no pronounced layers. So the glacial till is an example of an unstratified soil. And the example of stratification is that, for example, from the ground surface till 5 feet depth, you are having clay. Then after 5 feet till 10 feet, you are having sand. Then after 10 feet till 15 feet, you are having gravels. So this is like the distribution of soil particles or the accumulation or deposition of soil particles in pronounced layers. So this will be called as stratified soil. You can also categorize the soil system based on the cementitious properties. If the soil system is having some cementitious properties, then the soil will be categorized as cementing in nature. And if let's suppose the soil will not be having any cementitious properties, then in that case the soil will be categorized as non-cementic. Like for example, if you will mix water with clay, then its properties will change and it will become cementic in nature. Okay, after drying, then this clay will achieve some good strength. But vice versa is for the sand. If you will mix water with sand, then it will not change its cementitious properties, and after drying it will become again the grains of sand. Okay, so these are the few parameters with the help of which you can categorize your soil system. Then the three phases. You guys are there? All of you are there?
Yes, sir.
Yes, sir.
Or all of you are sleeping?
No, sir.
Yes.
Okay. So guys, the three phases of soil system. In this first line, this is basically the summary of the soil system. The soil consists of soil solids and airways. Okay. In soil, you are having the soil solids and the airways. Now, soil is different from most civil engineering materials in that it can simultaneously contain the solids, the liquid, and gas phases. Okay, as I have discussed with you, that in soil system there are particles which are known as soil solids, and some portion is free, which are known as airways. Now in this airways, this is an invitation for two things: for the gases or air, and for the water. Now for example, if all of these airways, this portion will be filled with the water, then in that case, the soil will be categorized as saturated soil. And if half of the air voids will be filled with water and half of the air voids will be filled with air, then in that case, the soil system will be called as partially saturated soil. And let's suppose if all of the air voids will be filled with air only, then in that case, the soil will categorized as a dry soil. Now let me explain this concept with the help of this diagram. Like this is a soil element, okay, a soil system. This is a cross section of a particular soil system in which you are having these soil solids, okay. You can see these are the examples of soil solids, and in between the soil solids you are having the free zones, and these free zones are known as air voids, okay. Now capital W will be the total weight of the soil system, which will include the weight of soil solids, the weight of air, and the weight of water, if any present inside the air voids. And this capital V is the total volume of the soil system, okay, which consists of the volume of the soil solids, the volume of the air voids, and the volume of the water, if any present inside the air voids, okay. Now let me discuss this in the three-phase soil element, okay, in which this bottom portion will be occupied with the soil solids, and the weight will be equal to the Ws, which will be known as the weight of the soil solids. And let's suppose if water will be present inside the air voids, then this zone will be reserved for the water, and this weight will be called as the weight of water. And let's suppose if some of the air voids will be filled with air, then this zone will be reserved for the air, and this weight will be categorized as a weight of air. Now as you can you know that the weight of air is much less, so we can approximate this as equal to 0. We will only take into account the weight of soil solids and the weight of water. Now further, this capital V volume will also be broken down into different categories like Vs, which will be known as the volume of soil solids, Vw, which will be known as the volume of water, and Va, which will be known as the volume of air present inside the air voids. Now this volume will be further divided into two portions. Like Vs is on its original location, Vs, which is known as the volume of soil solids, but this Vw and Va will be further divided into this Vv, which will be known as the volume of voids, okay. So this is the description of a three-phase soil system. Now keeping in view these volumes and these weights, we will derive some relationships which will be known as weight and volume relationships, okay guys.
Yes, sir.
So in this particular slide, now I will be discussing about the weight relationships, okay. Weight relationships are those relationships in which the weight part of the three-phase soil system will be used, like this part, okay. And the parameters that we will discuss will be the moisture content and the unit weight of the soil system. Now what is moisture content? Moisture content or water content, they are one and the same thing, and water content is basically the ratio of the weight of water to the weight of solids times 100, okay. So like this is the weight of water and this is the weight of solids. This ratio will give us what? This ratio will give us the weight of moisture or the moisture content present inside the soil system. If you are talking in terms of mass, so this will be known as the mass of water divided by the mass of soil solids multiplied by 100. In soil mechanics, we are treating the weight and mass as one and the same thing. Okay, now a small value of W indicates dry soil and a large value of W indicates wet soil. Their usual values lies from 3 to 70%. Okay, you can also have the water content more than 100%. Okay, like let's suppose this is a soil system in which only this zone is occupied by solids, and this zone is occupied by VW, weight of water. Now you can see that in this particular three-phase soil system, the weight of water is more as compared with the weight of solid. So if the weight of water is more as compared with the weight of solids, then this equation will give us value more than 100%. Okay, so you just keep in your mind that the water content present inside the soil system can be more than 100%. Okay, and if you are having water content equal to or greater than 100%, then it means that you are having a very soft style below the groundwater table. Groundwater table, the soil system beneath the groundwater table will be having a moisture content greater than 100%. Okay.
Yes.
Now, what is the unit weight of soil? The unit weight of soil can be defined with the help of this relation. Unit weight of soil is basically the weight of a particular soil system divided by the volume of that soil system. Okay, so that is the definition of a unit weight of soil system. When you will divide the weight of a soil by its volume, then it will not be known as a simple weight, but it will be known as a unit weight of the soil, and it is represented in soil mechanics as gamma. Okay, now you are having three types of gamma: gamma D, okay, gamma B, and gamma W. You can also have the fourth category, which is known as gamma SAT. Okay, so gamma D stands for the dry unit weight of soil, gamma B stands for the bulk or the moist unit weight of soil. It is also represented with gamma M, which is known as the moist unit weight of the soil. You can also have gamma W, which is known as the unit weight of water, and you can also have gamma SAT, which is known as the unit weight of saturated soil. Now, if you are talking about the dry unit weight, so in dry unit weight, we are doing what? We are basically using this expression: weight of soil solids divided by the total volume of soil. Okay, so when you are finding the value of the dry unit weight, so you just keep in your mind that you will include the only the dry weight of the soil system into this particular expression. If you are interested in finding the gamma B or gamma M, then you will incorporate the total weight of the soil system divided by the total volume of the soil system. Now this total volume weight of the soil system will include the weight of air, the weight of water, and the weight of soil solids. But if you are dealing with the weight of unit weight of dry soil, then only the dry part, the weight of soil solids will be taken into account. Unit weight of water is basically the weight of water divided by the volume of water. The usual units includes 9.81 kilonewton per cubic meter or 62.4 pounds per cubic feet. In every part of the world, these values are used. 9.81 kilonewton per cubic meter as the unit weight of water, or if you are dealing in FPS system, so you will use 62.4 pounds per cubic feet. Okay. Now, if all of the air voids will be filled with water, then in that case, the unit weight will be known as the unit weight of a saturated soil. Okay, in which this WA will be typically 0, and you will use what? WW plus WS divided by the total volume of a soil. Now let
Yes,
me
sir.
discuss some volume relationships with you guys. Okay, The common volume relationships are void ratio, porosity, degree of saturation, and the air content, in which we will only use the volume part of the three-phase soil system. Okay, only what?
Yes, sir.
Volume part of the three-phase soil
Yes,
system,
sir.
not the weight part of the three-phase soil system. So let me discuss the first parameter, which is known as the void ratio. Now void ratio is a very simple concept. It is the ratio of the volume of voids to the volume of soil solids. Now if your soil system is densely packed, meaning to say you have done the enough compaction of your soil system, then this will be known as a densely packed soil, and densely packed soil will be having our ratio values minimum. Okay, densely packed soil will have a lower ratio values, and the usual values in the field occurs in this range, starts from 0.1 to 2.5. Okay, 0.11 is for the densely packed soil, and 2.5 is for the loose soil. Okay, then you are having the porosity. Porosity is the ratio of okay, void ratio is represented by small e, and porosity is represented by small n. Okay, now porosity is the ratio of volume of voids to the total volume of the soils. Okay, in void ratio we were using the volume of voids divided by the total volume of divided by the volume of soil solids, but in porosity we are using the total volume of the soil system, this thing. Okay, so that is the difference between void ratio and porosity. Typical values lies in the field from 0.09 to 0.7. That is for the densely packed soil, and that is for the loosely packed soil. Degree of saturation of soil, which is represented with S. Okay, now degree of saturation is the volume of water to the volume of voids multiplied by 100. This part. Degree of saturation is the ratio of the volume of water to the volume of voids. Okay, only this part. Only this part. That how much volume is occupied by water and how much volume is occupied by in voids, how much volume is occupied by water is basically gives us the value of the degree of saturation. Now degree of saturation value can never and ever be greater than 100%. Okay, let's suppose if this is the volume of water, and this whole volume is occupied by water, okay, this whole volume is occupied by water, in this case this VV will be equal to VW. Okay, so if VV is equal to VW, then in the numerator and the denominator of the equation will be equal, and this will give us one value. So then this one will be multiplied by 100 and will give us a value of degree of saturation as 100%. S values above groundwater table are usually from 5 to 100%. In this range, the value of the degree of saturation will lie when you are talking about the groundwater table. Okay, but if you are dealing with the soil below the groundwater table, then the degree of saturation will be equal to how much? 100%, because all of the air will be filled with the water. If you are talking about arid regions, okay, arid regions are known as the drier regions, okay, in which the water table will be much deeper. Okay, so if the water table is much deeper, there is no rain in the area, then the degree of saturation will be equal to 0. How?
0.
Whole of the air voids will be filled with what? With air.
Yes, sir.
Okay, so then this VW part will be equal to 0. This VW part will be equal to 0. So if VW is equal to 0, this equation will give us value equal to 0. Got it?
Yes, sir.
So that's why we can say that in very arid regions, the degree of saturation will be equal to 0. And if you are dealing with the soil system below the groundwater table, then the degree of saturation will be equal to 100%. Now let me discuss another parameter which is known as the air content. It is also derived from the volume part of the three-phase soil system, and it is the ratio of the volume of air voids to the volume of voids. It is represented by small AC, which stands for air content. Okay. So this is the volume of air voids to the volume of voids. That in volume of voids, how much space is occupied by air. So this ratio gives us information about the volume of air voids only. So volume of the air only. So VA divided by VV is known as air content. As you guys know, volume of voids is equal to volume of air voids, plus volume of water. So if you will just rearrange this equation, like this will come on the left side of the equation and this will go on the right side of the equation. So you will be having this thing. Volume of air will be equal to volume of voids minus volume of water. Okay. So in respect of this volume of air in this equation, if you will put this thing, so this equation will be modified to this form: volume of voids minus volume of water divided by volume of voids. Okay. So if you will further solve this, so this will be equal to volume of voids divided by volume of voids minus volume of voids divided by volume of voids. So volume of voids divided by volume of voids will cancel each other, and this will give us what? 1 minus volume of water divided by volume of voids. And this volume of voids, water and volume of voids is what? This is the degree of saturation. So you can say that air content is equal to 1 minus degree of saturation. If you are having degree of saturation values for a soil system, you can indirectly find the value of air content by using this expression. Air content is equal to 1 minus degree of saturation. Got it? Now let me discuss the specific gravity of a soil system. GS. Okay. Specific gravity is the ratio of the weight of a given volume of a soil to the weight of equal volume of distilled water. Like, for example, that is the weight of soil equal to, for example, 100 gram, and the volume of this soil is equal to, let's suppose, 5 cubic centimeter. These are the supposed values. Okay.
Yes, sir.
The reality may be different. And on the other side, you are having what? Weight of water, which is equal to, for example, 50 gram, and the volume of that water, this is, let's suppose, also equal to 5 cubic centimeter. Okay. Now you can see the volume of soil is equal to the volume of water. So in that case, you can talk about the specific gravity, and the specific gravity will be equal to 100 divided by 50. In the numerator, the volume is constant 50 cubic centimeter, and in the denominator the volume is constant 50 cubic centimeter. So this is known as the definition of specific gravity. Now this equation will give us a value of specific gravity. How much? Q. This 50 is having no influence on the equation. This 50 is having no influence on the equation. This is only a definition of the equal volume. Okay? Like I'm discussing with you that specific gravity is the ratio of a given volume. Now given volume is how much? 5 cubic centimeter. Okay? And to the weight of equal volume of water, distilled water. Okay? Weight of what? Equal volume. Now equal volume is how much? 5 cubic centimeter. Meaning to say, if you are talking about the specific gravity of a soil, then you will compare that weight of the soil with the weight of what? With the weight of water. So water in this case is used as a benchmark. Okay? So in order to do this comparison, then the weight, then the volume of the soil will be equal to the, should be equal to the volume of the water. Then in that case, you can talk about the specific gravity. Let's suppose if Vs will be different than Vw, then this is not a specific gravity. It is all, then it is only a simple ratio. It will not be known as a specific gravity. So in order to talk about the specific gravity of the soil, the weight of the soil and the weight of the volume of the soil and the volume of the water should be equal. Now for most soil, you just keep in your mind that the value of specific gravity is from 2.6 to 2.8. Okay, usually the value of specific gravity of soil we are taking is 2.65. Okay, if you will be not having information, or if you will be not having any physical tool with the help of which you can compare the specific gravity of a soil system, then you can use 2.65 as a standard value. Okay guys, now specific gravity in the lab can be found in different ways, like picnometer method, SSD method, density bottle method. Density bottle method is for the clay soil, clay and silty soil. Picnometer method is for the sandy soil, and SSD method is for the gravelly soil. I will share with you the videos of these procedures. Okay, this
Right.
procedure is present on my channel as well. That how can you find the value of specific gravity of soil by density bottle method. You can watch there the value of SSD specific gravity. This method will be uploaded soon. Okay, and picnometer method and density bottle method are the same. Only there is a little difference which I will share with you later on. You just keep in your mind that these are the different methods with the help of which you can find the specific gravity of soil systems in lab. Now let me discuss another soil parameter which is known as a relative density of soil. Relative density is represented with dr, okay, and it indicates the in situ compactness or looseness of granular soil. Okay, and this is find out with the help of this expression Emax minus E divided by Emax minus E minimum, in which E stands for the void ratio. Now E is the specific, is the void ratio of the soil in the natural state. Okay, E maximum is the void ratio of the soil is in the most loose state. Okay, like when the soil particles will be away from each other, there will be voids among the particles, and VV will be more as compared with the VS. So this equation will give us value which will be greater as compared with the E minimum. Now E minimum is the value of the void ratio of soil in the most compacted state, when all of the air voids will be, I would rather say, negligible. They will be removed with the help of artificial compaction methods. So you can say that E minimum is the void ratio of the soil system in the most loosest state, and E maximum is the void ratio of the soil system in the most densest state. Further manipulate the value of the relative density of soil for the description of soil deposits. Like if this value will be from 0 to 15, then the soil will be in the very loose state. 15 to 50 is for the loose soil, 50 to 70 is for the medium soil, 70 to 25 is for the dense soil, and 85 to 100 is for the very dense soil. Now let me derive some E and N relationships like this. E is equal to N over 1 minus N. N is equal to E over 1 plus C. So how this expression came, let us discuss. Let me first discuss the wide ratio expression. E is equal to N over 1 minus N. That is the definition of the wide ratio. Wide ratio is the ratio of volume of voids to the volume of solids. Okay. Now, total volume of a solid system consists of what? Volume of voids plus volume of solids. So if you will rearrange this equation, then you will be getting the value of the volume of solids is equal to total volume of soil minus volume of voids. So instead of Vs, I will write capital V minus Vv. Now I will do another thing. I will divide the numerator of the equation by capital V and the denominator of the equation by capital V. Now you know that Vv divided by total V is what? That is N. Okay?
N.
And if you will further modify this equation, then this will be equal to capital V divided by capital V minus Vv divided by capital V. This will be cancelled. So this will be equal to 1 minus Vv divided by capital V. Now Vv divided by capital V is what? That is your porosity. So this is how you can derive the expression for a wide ratio of soil in terms of porosity. E is equal to N over 1 minus N. Now let me discuss that how we can find this expression for the porosity of soil in terms of wide ratio. The definition of porosity is this one. N is equal to volume of void divided by the total volume of soil system. Now you better know that total volume of soil is equal to the volume of solids plus volume of voids. So instead of total volume of soil, I will write down volume of solid plus volume of voids. Now I will divide the numerator of the equation by Vs and the denominator of the equation by Vs. Now you better know that Vv divided by Vs. Vv divided by Vs is what? Your wide ratio. In my previous slides, I have discussed with you. And this Vs divided by Vs will give us 1, and this Vv divided by Vs will give us what? Wide ratio. So this is how you can derive the expression for porosity of soil in terms of wide ratio. And porosity of soil will then become N is equal to E over 1 plus E. Okay guys, so this is how you can derive some E and N relationships. Now there are other derivations as well. Okay, if I will just switch towards the derivation, then I think I will be needing one more class for the derivations, and there is no need to derive these expressions. Okay, we as a technologist are required to just use this expression for finding different soil parameters. We are not supposed to derive this expression because I think that is just a piece of bullshit. Okay, so let me just share with you these weight and volume relationships which you can use for some useful purposes. Like if you will be having one physical property of soil, then you can find out the other physical property of soil which will be of interest to you guys. Okay, so the first expression is E is equal to N over 1 minus N. The second expression is N is equal to E over 1 plus C. The third expression is WC is equal to E into S divided by GS, where WC is the water content of the soil, E is the wide ratio, S is the degree of saturation, and GS is the specific gravity of the soil. The fourth expression, gamma B. Gamma B is the bulk unit weight. It is also represented with gamma M, which will be known as the moist unit weight of the soil. It is equal to gamma W, the unit weight of water. GS is the specific gravity into 1 plus water content divided by 1 plus void ratio. The fifth expression is gamma B is equal to gamma W into GS plus ES divided by 1 plus E. The third expression is gamma D. Gamma D is now the dry unit weight. Dry unit weight is equal to gamma W into GS divided by 1 plus E. The seventh equation is gamma D is equal to gamma B divided by 1 plus water content. Okay, so if you are having the value of the bulk unit weight and the water content of the soil system, then you can find the dry unit weight of the soil system. The eighth expression is gamma submerged is equal to gamma W into GS minus 1 divided by 1 plus C. The ninth expression is gamma saturated is equal to GS plus E into 1, GS plus E into unit weight of water divided by the 1 plus C. The 10th expression is E is equal to GS into unit weight of water divided by unit weight of dry soil minus 1. So these are the expression that I think you just learn by heart, because in different competitive examinations we are given with the value of the degree of saturation and the value of water content and the value of specific gravity, and they are asking to find the value of what? The value of void ratio. So by playing with this equation and some given data, you can find the value of what? The value of void ratio. Sometimes they are giving that the value of water content is that much, the value of specific gravity is that much, the value of void ratio is that much. Now find us what? The degree of saturation. So in this case, you will be playing with this equation. Sometimes they are giving us the value of moist unit weight in the water content of the soil system, and they are asking for the gamma D, which is the dry unit weight. So in this case, you can manipulate this equation. Sometimes they are asking for the value of the void ratio, and they provide us with gamma D and GS value. Okay, gamma W is universal constant. In MKS, it is 9.81 kilonewton per cubic meter, and in FPS system, it is 62.4 pounds per cubic feet. Okay, so that is the usefulness or the use of these 10 formulas. I will recommend to just learn by heart these 10 formulas.
Okay, sir.
Let us solve different numerical problems. Okay. Tests are made to determine the maximum and minimum void ratio for a sand, and it is found that E minimum is 0.5, E maximum is 0.7. A well compacted sample in the field is found to have a void ratio E equal to 0.55. What is the relative density? What is the relative density? Okay, we are having 4 options: A 25%, B 55%, C 100%, D 75%. So the expression is what? This is the expression. The relative density is E max minus E divided by E max minus E minimum. E max is 0.7, E is 0.55, E minimum is 0.5. So solving this equation, you will be having the value of relative density is how much? 75%. So your correct answer is what? It is option D, which is 75%. Okay. So this type of small numericals and MCQs may come in your competitive examinations. Okay. Now, second numerical. The soil specimen is my earth. Okay, and its volume is determined to be 0.011 cubic feet. In a moist state, the sample weighs 1.2 to 1.2 pounds. In the soil will be in the moist state. Okay, then its weight will be how much? 1.2 pounds. Now after drying overnight, the sample weight is how much? 1 pound. Okay. Determine the moist unit weight and dry unit weight. Okay, guys. So when I was discussing with you the moist unit weight of the soil system and the dry unit weight of the soil system, then I added that whenever you will find the value of the moist unit weight, then you will be using the total weight of the soil system, which will include the weight of water, the weight of air, the weight of soil solids. Okay, so that will be like the weight of the soil in the moist state. If you are talking about the weight of unit weight of dry soil, then at that case you will only add the weight of soil solids, which will be known as the weight of dry soil only. So in the statement it is given that the weight of the soil in the moist state is how much? 1.2 pounds. So if you are dealing with gamma M, the unit weight of the moist soil, which is also known as gamma B, you will add how which value of the weight? This 1.2 pounds, because that is the weight of the soil sample in the moist state divided by the volume of the soil system, which is known as 0.011 cubic feet. So this will be equal to the value of gamma B, 109.1 pounds per cubic feet. Now, if you are talking about the gamma D value, then in gamma D you will be using the weight of soil solids, which will be known as the weight of dry soil. Okay, so after drying overnight by using the ESTM oven drying method, the after weight is how much? It is 1 pound. So you will use which weight? This 1 pound divided by the volume of the solids, which is 0.011 cubic feet. So this equation will give us the dry unit weight of the soil is 90.9 per cubic feet, pounds per cubic feet. Got it? Now,
Yes,
numerical number 3. A moist soil sample weighs 10.2 pounds. How much? 10.2 pounds. Okay? When the soil will be in the moist state, okay? In the wet state, its volume is 0.08 cubic feet. So, its water content was calculated and it was found to be equal to 21.3%. Now calculate moist unit weight gamma B or gamma M and the dry unit weight. Okay, so for the gamma M I will use which weight? The weight of soil moist state, which is equal to 10.2 pounds divided by the volume of the soil, which is equal to 0.08 cubic feet. So this equation will give me a value of the unit weight of soil in the moist state is equal to 127.5 pounds per cubic feet. Now, if you are interested in converting this moist unit weight into dry unit weight, then you will use which formula? You will use formula number 7. Gamma D is equal to gamma B divided by 1 plus water content. If you are interested in converting the percent water content to the decimal, then just divide this by 100. Okay. So gamma D after this will be equal to 105.1 pounds per cubic feet. Okay, guys. So this is how you are converting the wet unit weight of the soil system into dry unit weight. Numerical number 4. A soil sample weighs 16.2 pounds when moist. Okay. When the soil system will be in the wet condition, the weight will be equal to 16.2 pounds. Its weight after drying is 13.1 pounds. Its volume is 0.15 cubic feet. Calculate the sample void ratio. The solid specific gravity is 2.68. Okay, so you are supposed to find the void ratio of the soil only. Okay, so for the void ratio of the soil, I'm having this expression: GS gamma W divided by gamma D minus 1. Okay, this formula. Formula number 10. GS into gamma W divided by gamma D. Okay, gamma W is universal constant, no problem. And GS, I think it is given in the equation. Yeah, GS is also given 2.68. But guys, what about gamma D? Gamma D is not given in the equation. For the gamma D, okay, I'm having a very simple relation. Gamma D is equal to gamma M divided by 1 plus water content. But I'm really sorry, I don't have gamma M and gamma W and water content as well. So first I will do what? I will find the value of the water content of soil and the moist unit weight of the soil. Okay, I will come in reverse order. Now first of all I will find the weight of the moisture content value. So for the moisture content value, I'm having a very simple expression that water content of a soil solid is equal to weight of water divided by the weight of soil solids. Okay, so when the soil will be in the wet state, its weight will be equal to 16.2 pound. But when it will be in the dry state, its weight will be equal to 13.1 pound. So subtracting the dry weight from the wet weight will give me the weight of water, okay, which will be equal to 16.2 minus 13 divided by the weight of dry soil. So after drying, the weight which will be achieved will be equal to the weight of dry soil, and it will be equal to the weight of soil solids only, and its value is equal to 13.1 pounds. Multiplying this with 100, I will get the value of the moisture content of soil is 23.7%. Now, calculating the moist unit weight of the soil. For this, I am given with the moist unit weight and the volume of the soil system. So the moist unit weight is 16.2 pounds and the volume is 0.15 cubic feet. So this will give me gamma M value is equal to 108 pounds per cubic feet. So now I can talk about the gamma D. For the gamma D, I have found out the gamma M value and the W value. Okay, so gamma M is now with me is 108 pounds per cubic feet divided by moisture content is 0.27237. Okay, so it will be added with 1 to give me a value of 1.27. This will give me a value of gamma D equal to 87.3 pounds per cubic feet. Now I am having the value of gamma D, GS, gamma W minus 1. So feeding all data into this particular equation, now I have found out the value of water, the value of void ratio equal to 0.916. So numerical number 5. In numerical number 5, a soil sample measured volume is 30.7 cubic inches. The moist unit weight is 1.87 pounds. The water content was determined by oven drying method and it is equal to 22.5%. The specific gravity of the soil solids is equal to 2.68. Okay guys, now I am given with the volume in cubic inches 30.7. The weight in pounds is 1.87. The moisture content in percentage is 22.5%. Specific gravity is 2.68%. Now guys, as other units are in pounds, so I will also convert this volume into cubic feet. So you just keep in your mind that 1 cubic feet is equal to 1728 cubic inches. Okay, so this will convert this 30.7 cubic inches into 0.01777 cubic feet. Now I am having this equation that the moist unit weight is equal to moist weight divided by the volume. So moist weight is 1.87 pounds and the volume is 0.01777 cubic feet. So this will give me a moist weight of 105.3 pounds per cubic feet. Gamma D I can find out with the help of gamma M divided by 1 plus water content. Water content is given in the expression. Gamma M I have found out. So this will give me a gamma D value. From the gamma D, I can calculate the value of void ratio. Void ratio is equal to GS into gamma W divided by gamma D minus 1. GS is given, gamma W is universal constant. Gamma D I have found out and its value now is 85.9. This expression will give me the value of void ratio as 0.946. Now porosity is very simple. Porosity is equal to E divided by 1 plus E. E is equal to 0.946. So this expression will give me a value of porosity is equal to 48%. Now I'm interested in finding the water content. So for the water content, I'm having this formula: ES divided by GS. Okay, ES divided by GS. Now over here, you can see it is only E divided by GS. Why? Because over here I have written a value of saturated. So for the, if you are interested in finding the water content of the saturated soil, now you just keeping in your mind that the water content for the saturated soil is equal to how much of 100%. So in this expression, I have already put the value of moisture content is equal to 1 in decimal form. Got it, guys? So not in decimal form, over here it is written as 100%. The value of void ratio is equal to 0.946, and specific gravity is given in the expression as 2.68. So this equation will give me the unit weight of the saturated soil, which is equal to 35.3%. Okay, guys, I'm done with my today's lecture. If you are having any questions, you can ask right now, or you can ask in your WhatsApp group. So I'm
Okay,
done with
sir.
my
Thank you,
today's
sir.
lecture. Thank you, guys, for your participation. God bless.